My name is Dominic. I'm the host for today's webinar. All of you must be aware the reason behind this webinar and the title, Hospital Don't Burn. You know, very controversial statement that we are making. Hospitals at risk, understanding why short circuits do happen. So today we meet at a time when India is witnessing an alarming number of hospital fire incidents. Over 105 fire accidents have been reported in healthcare facilities since 2020. These are not just statistics. Behind every number is a life lost, a family devastated, and system that failed to protect most vulnerable patients in ICU, in NICU ward, who cannot even move to safety or refuge area. The question we ask today is, why are hospitals, that very place meant to save lives, becoming death trap? Is it negligence? Is it because of ignorance? Or is it wrong electrical design? Or our simple chalta hai attitude? Chalta hai attitude is nothing will happen here because this facility is there since 20 years, 20 years. Nothing's going to happen. It happened somewhere else, but it's not going to happen. That is called chalta hai attitude. So the National Federation of Engineers for Electrical Safety, in short we call NFE, has been a crusader for change, spreading awareness, training professionals, and advocating compliance with the National Electrical Code of India 2023. Yesterday, Mr. Gopakumar was in Dehradun. A day before, he was in Nagpur talking about National Electrical Code of India. He landed in Chennai at 4:30 in the morning, and is today is front of you addressing 1,300 plus engineers and professionals today. So through this webinar, NFE aimed to highlight the practical method to prevent electrical fire, detect short circuit easily and very early, and monitor the fire spread in real time using today's technology. The electrical fires are preventable, and preventions begin with knowledge, accountability, and compliance. So today our goal is to turn awareness into action to ensure no patients, no staff, no doctor ever face such horror in a hospital again. We are privileged to have our president, Mr. Gopakumar S. Is an expert member in BIS and NBC and NEC committee. I will talk more about him in the next couple of slides. So let's begin today's session with the shared sense of responsibility to learn, to question, to commit ourselves to building safe, resilient, and compliant hospital across India. I will also talk a little bit on how to monitor the fire protection system, how the fire detection can be monitored remotely anywhere you sit. So today's topic is our hospital at risk. And I want to, before I begin, before Mr. Gopakumar comes, I want to talk a little bit about NFE, National Federation for Electrical Safety, which began with a humble initiative under the Vidyut Surakshit Bharat Abhiyan. That's during the COVID time. Mr. Gopakumar single-handedly took that challenge in association with Kerala government and a couple of others. So the mission to make electrical safe nation. In a very short span, we almost know 2.5 years, NFE has grown as one of the fastest growing society in India, with over 2,500 members and 12 active chapters across the country. So through relentless effort, so it has conducted over 180 webinars. Though if you go to our website, nfes.org, you can find all these webinars, recording whether it is earthing, whether it is a lighting protection, various subjects. fault loop impedance. So we have covered 180 webinars and over 50 workshops, 50 physical workshops. We have traveled length and breadth of the country. Every city, today we are covering tier 2 cities like Dehradun, in Bhubaneswar. We are going to remote places. What our mission is, where there is electricity, the NFE should be present there to educate people on electrical safety. So we've been associated with Bureau of Indian Standard, promoting the National Electrical Code of India and best practices in electrical design and safety. NFE's recently concluded ElectSafe, which has become a platform to showcase innovations, safe product, and real-world solution to prevent electrical fire and accident. So this is going to be year-on-year event, ElectSafe, which will be next year, which will be held in Ahmedabad in 2026. So we began this movement, and today it became National Crusade, uniting engineers, consultants, safety officers, institution to drive awareness and education. I would request everyone, those who are joined today and will be joining shortly, please become a member of NFE. You will gain, I promise you will get to understand about standards and code, best practices, the failure, the case studies. The learning is endless. So the membership cost just, it'll cost you 1,000 rupees a year. And for those who are corporate, it just costs you 5,000 rupees. MSME 2,500. We have 1.3 billion population. In that, if you take around 2.5 to 3% are engineers. Electricals are few lakhs. If all the electrical engineers, practicing electricians, they become a member of NFE, the nation can at least move to the next level of advancing the electrical safety and become a developed nation. A developed nation cannot be on just economic. It has to be safe. It has to be secure. So one step that we have taken is to bring NFE to forefront to educate people. We need engineers to come forward. We need more people to go to remote places and talk about electrical safety. Our mission is very clear. Make every electrical installation free of accident. Our mission is to strive to achieve our vision through getting accredited of products and personal certification. So we need every electrician to be certified, every engineer, every consultant to be certified. So what we do create awareness, we move around the country, talk about improving the skill. Skill development is a continuous process. So this is our membership fee for the association. I'm sure today we will have good number of members joining as NFE and supporting our cause and joining hand. You can be a fantastic speaker. Please do join us and we can take your knowledge to the world. So today we have our president, Mr. Gopakumar, who has been moving around the country. And as I said, he just landed from Dehradun. So he runs his own business under the name Cape Electric. He also he produces electrically through windmill. So Cape Electric Power Production. And he also has a LP Consultant International. He's a member of technical committees of BAS, IEC, and NBC. He is a committee member of ETD 20, ETD 30, ETD 50, and also is a drafting committee member of National Building Code, CED 46, Part 13, and also ITD 09. Under IEC, he participates in MT3, MT12, MT40, MT41, Working Group 43 of IEC TC 64. And so forth. The very short profile of Mr. Kumar. He has a list of at least 5 to 6 pages that I can read out today. But due to short of time and the interest of today's topic, I would like Mr. Kumar to take over. Myself, as I said, I am the founding member of NFE and I take care of marketing and development of NFE. I'm a founder of FSA, Fire and Security of India. I was the General Secretary and President of that. And there's another society called Focus, Forum of Construction Utility Services. and CLF, Council of Fire and Life Safety Group. So I'm also part of NBC 2023 in the fire and life safety. So after Mr. Gopakumar completes, I will just take 2-3 slides on how to monitor the fire system in your building, how to respond to any cause alert. So I would welcome our Mr. Gopakumar to take over from here. Uh, Welcome, sir. We have fantastic gathering. As I said, we have 1,300 plus registration, and people are hungry to get the learning and develop their skill. Over to you, sir.
So, good morning, ladies and gentlemen. We have fantastic participation today. The reason for making today's webinar, as all of you know, last week there was a massive fire accident in one of the hospital and 8 people passed away. Such accidents are becoming quite common in our environment. A lot of fire accidents are happening. Of course, out of 100 fire accidents, only one or two are coming out as in the news. There are hundreds happening where there is no news coming out because these are, sometimes minor fire hazards. Now, when it comes to electrical safety, there are several engineering solutions possible. These engineering solutions are being developed during the last few decades, maybe 50, 60 years. One of the first problem which we need to identify or which we need to handle is fire from electricity. That means electrical appliances, medical electrical equipment should not create fire, should not ignite fire. If we look at the statistics in India, almost 70 to 75% of fire accidents in India are ignited from electricity or due to electrical reasons. In medical location, it is not only the fire. Another most important subject is electric shock, because biomedical equipment are bypassing the skin. Normally, resistance to electricity is offered by the skin in a human being. Once when you bypass the skin, and once when you place applied parts into the body, the chance of electric shock is extremely high. Similarly, the problems due to EMI, electromagnetic interferences, that means the screens are not visible properly, there are grains, and sometimes you may have to take a decision based on the data which is there on the screen, and if the screen is not visible properly, then the medical practices can be in trouble. Electrostatic discharge and electrostatic accumulation. There are multiple problems which need to be very carefully handled in a hospital. Please don't expect one device offering solution for all these problems in a hospital. It is not possible. Engineered solution, multiple of engineered solutions are required to handle these issues. We will explain some of the solutions today, not all the solutions, some of the important solutions which I felt are important. Now, as Mr. Dominic told about me, myself, I am Gopakumar. I'm a member in this MT40 of ICTC 64. MT40 is the technical group, global group, making electrical safety standards in medical locations. And the standard, which we call as IEC 603647710, is being used all over the world for creating safe electrical environments in hospitals. In Americas, in Europe, Japan, Malaysia, all over the globe, the same standard is used. In India, the same standard has been adopted as a part in National Electrical Code as well as IS 17512 and so on. Today's my presentation, I am trying to focus on the subjects as listed here. The first one is National Electrical Code of India and history of development of the engineered solution. Medical equipment and applied part, patient environment and zone of risk, medical locations and classification, examples of safety requirements such as in the UPS, battery and safety service, protective earthing and examples, disconnection time and its efficiency, medical IT system, safety from electrostatic discharge, initial and periodic verification, Then we go to the challenges which the industry is facing and some of the tips to improve. So, the first one, the history. For the first time in India, electrical safety in hospitals are being introduced in 1985 in the National Electrical Code of India. As you can see here, Section 4, medical establishment. So, this particular standard was talking about safety requirements in the entire hospital. Also, you can see on the right side, provisions, principal requirement, and installation measures. The first one, P0, the safety measures are classified from P0 to P7 and some special additional measures, duration of touch voltage restricted to safe limit. Like this, different methods are being introduced in 1985. The 2011 version of the National Electrical Code further improved the content. The systems are almost the same. Basically, these are from the standards established or existing during that time, or those standards which were used during that time. One of the requirement is classification of medical location. Medical location means an area. I will explain it later. The hospital management should classify the area and ensure that additional safety measures are made in these locations. In 2023, NEC has been revised again. Now, the safety from medical establishments, it is changed to medical locations. Medical establishment is having a wide meaning, means the entire hospital. Medical location means an area where some kind of treatment activities are going on. That is the difference. But NEC as a whole, it talks about the entire establishment, because the part 1 talks about the entire establishment, section 9 talks about medical locations. That is how it is. The first job, once when you construct a hospital, is to find out the risk and to create an electrical distribution strategy. The electrical distribution strategy has been made based on risk to patients due to loss of supply. In the sense, patients are connected to the life-saving equipment, and once when the life-saving equipment, the power supply to the life-saving equipment is either stopped or the supply is stripped, the protective device stripped, then there is a risk of loss of life to the patient. Similarly, a risk to business continuity due to loss of supply. So one of the first job to be made is to create an electrical distribution strategy. In the next slides, I am trying to explain you how scientifically this has been made or developed during these years. In a medical location where a medical activity is going on, a clinical process is going on, medical electrical equipments are required. We call them as biomedical equipment. The correct technical term is medical. ME stands for medical electrical equipment. MES stands for a combination of medical electrical equipment, which is called as medical electrical system. They are classified into class 1 and class 2. Like any other electrical equipment, normal electrical equipment which we use in our houses are classified as class 1, class 2, and class 3, whereas medical electrical equipment, there are only two categories, class 1 and class 2. And these equipments have applied part. Applied part are basically the part of the machine which is in touch with the patient's body, or it has to be brought in contact with the patient, or the patient need to touch somewhere. So the parts which is in contact with the patient's body is called as applied part. They are categorized into P, BF, and CF based on the type of application, type of its criticality. Examples of type B applied part is the hospital bed, for example, because the patient is on the hospital bed. That is one example. Or the bore or table of patient MRI scanners, phototherapy units, the light fittings, ventilators, the main unit of the machine, all these are classified as type B. Type BF, insulated part floating safer than B. In this particular case, the blood pressure cuff, the ultrasound transducers, the probe, infant incubators, the component, and the temperature probe that controls the infant, a pulse oximeter, the sensor attached to the finger, all these are classified as PF. CF is much more safer. CF is used for intracardiac sometimes, or cardiac or intracardiac applications. Example, the ECG lead of a cardiac use, defibrillation pads, the pad placed on the chest or dialysis machine, surgical equipment, all these are classified as, or parts of this equipment are classified as P. So the first job is, equipment are classified into class 1. The applied part, which is used on the patient body, is called as applied part. Here there is an example, the single line diagram. Sometimes this may feel, my explanations may feel very too much technical for the participant, but please listen. There are some tips which I wanted to give you. The block diagram of a medical electrical equipment. In India, there is a standard for medical electrical equipment, IS 13450. These equipment are to be certified by some agency, and only certified equipment are supposed to be used in the hospital. Now, the classification, class 1 medical equipment, very simple to identify. These are equipment which is having a 3-pin plug. 3-pin plug for a single phase. 3-pin in the sense there is a phase, neutral, and earth pin. Class 2 equipment, generally they are equipment with 2-pin plug. The device which is having 3-pin plug, one of the pin is earth pin, protective earth pin. Whereas in a class 2 equipment, you don't need to have earth pin. So equipments are very much classified. The hazards created by these equipments are already listed in the standard. If you are using an equipment which is tested as per the standard, you can be sure that yes, the safety is already taken care for the equipment. Safety measures for the equipment are already taken care by the equipment manufacturer. Now, what the hospital should do to further improve the engineering practice, there are certain terms defined in the standard. Example, patient environment. An area up to 1.5 meter distance from the intended location. The patient environment is 1.5 meter. There is a chance that somebody may touch the patient, or somebody is standing there doing something with the patient. Somebody may touch a doctor who is touching the patient's body. The chance of touch is much more to the patient. Patient is already unconscious. He is connected with the medical electrical equipment, probably bypassing the skin. The chance of shock to the patient is extremely high. Within the patient environment, the chance of potential difference must be avoided so that the life of the patient is taken care well. A study by international investigative journalists in USA, they published it a few years back. According to them, thousands of patients are dying in operation theater, not because of an ill treatment, but because of electric shock. These protective measures are not very well maintained. As a result, the patients are getting killed. Now, the safety measure to be implemented here is, as you can see here, the patient environment. Within the patient environment, no chance of shock. Explosion risk. Explosion risk in the sense, imagine there is a small fire which is happening in a location. Now suddenly, if oxygen from some of the pipes is introduced additionally to this particular area, this small fire can become an explosion. Anesthetic gases are sometimes explosives. It may create explosion. Now, each of these equipment, the area with which flammable mixture of these gases are present are being already found out in the standard. They are classified as zone G and zone M. Zone G means the concentration of the gas is very high. Zone M means in case of when somebody is using, when the patient is using, there can be an area where the gases, anesthetic gases are accumulated more so that the chance of explosion are more. These areas require additional safety measure against ignition of fire as well as, spread of fire. Very, very important. Medical location. They are classified into Group 0, Group 1, and Group 2. Group 0 is a medical location. Medical location in the sense maybe a room or an area in a hospital. Group 0, medical location where no applied part are intended to be used. Nobody is using, applied parts are not used in a Group 0 location. Group 1 is a medical location where applied parts means the parts of the biomedical equipment which is touching the body of the patient, they are used externally or invasively to any part of the body except Group 2 location. In a Group 1 location, even if the electricity supply is disconnected, the patient is not in danger. Group 2 medical locations these are locations where applied parts are intended to be used in applications such as intracardiac procedure, operation theaters, and vital treatment. In these locations, if the power supply fails, the supply failure can endanger the life of the patient. So basically, medical establishment means the entire hospital. Medical location means Group 0, Group 1, Group 2 locations where some kind of medical activities are going on. The critical ones are Group 1 and Group 2 locations. Group 1 and Group 2 require additional safety measures. One of the first job of the management of every hospital is to identify these locations. The National Electrical Code of India, as well as the international standards, American standard or German standard, whatever. The Indian standards, especially the NEC, provide you this kind of a table, medical location, classification of medical location based on the application. Example, you can see endoscopic room. It's Group 1 location. Hydrotherapy room is a Group 1 location. On the right side, you can also see class. This is the class of power supply, the maximum allowed time for the changeover in case of power failures, changeover from one source to the other source. Similarly, anesthetic room is classified as Group 2 location, operation theater as Group 2 location, operation preparation room can be Group 1 or Group 2. It depends on the activity which is going on. So like this, the first job of the management is to electrically classify the entire area in the hospital where electrical, biomedical, or some kind of medical applications are going on. Now, the medical staff, the management, electrical expert, as well as the operational people should sit together and decide this particular subject. For example, operating plaster room, it can be Group 1 or Group 2. It depends on what activity is going on. In some hospitals, probably it's a Group 2 location. In some hospital, probably it's a Group 1 location. It depends on the actual activity you are doing. Ideally, every hospital must have a list in the electrical room or in somewhere where it is accessible to the management with a list of rooms medically categorized as Group 1, Group 2, and Group 0 locations. And this technically it has to be provided to the insurance company as well as it has to be provided to the safety auditor who is coming. Unfortunately, this subject, as I said, please note that this is not a new subject, but it is being started in 1985 in India. In Europe, this is started during 1960s and 1970s. In America, again, during 1960s, this practice started. So it's time for us to start this practice. Make a list of medical electrical equipment used, medical electrical rooms used, then classify them as Group 1, Group 2 locations. Use of UPS. Most often, we have the habit of using UPS without isolation transformer. The technical word is called as electrical separation. We have a three-phase UPS. There is no separation, there is no isolation transformer, and the load are single phase, which need a neutral. Now the neutral from the main supply is sometimes used, which creates confusion, which creates circulating current in the entire system. The ideal situation for a hospital is to have UPS with isolation transformer. For a three-phase UPS, if the connected load have single-phase equipment, electrical separation between upstream and downstream is mandatory. You must use with isolation transformer. This avoid neutral circulating current and control harmonics to a great extent. Please take care of this. Battery in the UPS, another important subject. During charging of the battery, gases are emitted from all secondary cells. Gases produced are mainly hydrogen and oxygen. If the concentration of the gas, especially hydrogen, if the volume is 4%, more than 4% of the volume of the air, then there is a chance of explosion. Now, in this particular location, you need ventilation, which can be provided either by natural means or by forced ventilation. The subject is very much engineered and included in the respective standard, depending upon the size of the battery, type of the room, type of ventilation. We can exactly calculate the ventilation requirements, and then the management can decide whether you need a natural ventilation or a forced ventilation. Please note, on the right side, you can see some kind of calculation from IC 62485 part 2. Here, this standard is providing the engineering solution for identifying a location where the battery is kept and what kind of ventilation is required. Safety service. It is a requirement in the Indian safety regulation that in an accessible position, there should be a switch which has to be operated or which can be operated during an emergency. And with one switch, the entire supply to the building can be disconnected, except the safety service. Now, in this particular subject, the interesting points which we need to take care is first one, the location and the operation of fire switch, who can operate it, where it is kept. The second subject is IT system for services, safety service. Safety services, continuity of supply is important, so IT system can be thought of. Separation of wiring for safety services from the other normal electrical wiring is necessary. Wiring system and type of wires is important. Emergency lighting is important. Power supply for fire detection and firefighting is important. All these subjects are also covered in the respective standards, but please note that it is not like there is only one method which you can adopt. No, it is not like that. You have to conduct a study and find out the optimum, the maximum possible safety measure for your hospital. And engineered solutions are already identified and written in the standard. Safety service. They are classified as Class A, Class C, Class E, and Class F. Class A means there is no break, there is a continuous power supply. Class C means there can be a break of up to 0.5 second. Class E for 15 seconds and Class F more than 15 seconds. The application of these are very well again included in the respective standards. Like for example, installation of fire pump, you can look at this. Rated operating time is 12 hours, and a response time, the changeover response time is maximum 15 seconds. Smoke and heat extraction equipment. The rated operating time of the source must be capable of providing the electricity for up to this much time. Say, for example, 3 hours with 15 seconds changeover time. So now various applications and various, these selections are very well defined in the electrotechnical standards. One subject which is of very, very extremely important in medical location in hospitals are earthing. By looking at the word earthing, generally, biomedical engineers and electrical engineers, or normally the experts think that earth, what is earth? Earth means soil. So people try to make earth in the soil, which is absolutely wrong. Here you can see sub panel, motor, these are exposed conductive parts. Then your building has got extraneous conductive parts. Connecting all the dead metal parts in your building to a common bus bar in a typical fashion is earthing. Now the MET has to be connected to the neutral of the source. This is a TNS system and this is earthing. As I put here, no reliance to earth electrode in soil in case of a TNS system. And we are supposed to follow TNS system in a medical facility because today's biomedical equipment are demanding TNS system. Please note, earthing has nothing to do with earth electrode. Earthing is a measure, a safety measure with which potential differences, voltage differences within a building is limited by bonding conductive parts to a common bus bar. This is earthing. Example, you can see here a Siemens, a GE machine. You can see here power supply, three-phase plus G means it's a TNS system because this machine doesn't need neutral. Frequencies, capacity. Now you see one parameter which is very interesting, maximum line resistance. The old name is line resistance, which is already changed to line impedance. So this machine ideally should have, let's say, a 415 volt or 440 volt to 0.20 ohm. So 0.2 ohm, 200 milliohm is the impedance of the circuit, maximum allowed impedance of the circuit for this particular equipment. So ideally, the equipment supplier, while connecting his equipment, he is supposed to measure. Now you see the equipment very clearly explains the requirements of earthing and grounding. Unfortunately, in India, there is a practice by the medical equipment suppliers. They ask for separate earth electrode and they ask for 1 ohm, less than 1 ohm earth electrode. Please note that nowhere in a medical electrical standard, a separate earth electrode, connection to a separate earth electrode is required. The demand from the medical electrical, biomedical equipment companies are absolutely wrong. The maximum allowed resistance, as you can see here, 0.2 ohm. It's not 1 ohm. It is much, much lower. It is 0.2 ohm. Another equipment, an example, you see Siemens. The electrical parameters, if you have a manual of this particular machine, you can look into the electrical parameters. It says mains should be TNS, of course, TNS, very clear. The line impedance shall be lesser than 100 milliohm. One question which I seriously wanted to ask all the medical electrical equipment companies are you seriously measuring the line impedance? The reason is, this machine is having an inbuilt fuse inside. The purpose of the fuse is once when the machine catch fire, the fuse should blow or the fuse should disconnect the supply much before the electrical appliance ignite fire. Now, if the line impedance is larger, higher than this particular value, you forget, the fuse will not work. It becomes fire. The NEC in 1985 gave examples of methods making equipotential bonding or earthing in a hospital, 1985. All these green connections, see there is a green connection, I'm sure you are able to see the cursor I am moving. There is a green connection. This is the earthing. Finally, the entire metallic parts are bonded to serial number 19, which is the MET, main earth terminal. 1, 2, and 3 are heating pipe, water supply pipe, gas pipe, and so on. Now 7, again heating or gas pipe. All the metal parts must be bonded to a common bus bar. The biomedical equipment also must be bonded to the same common bus bar with a very low resistance connection. And now you see 1985, finally the entire system is connected to the structural steel of the building, and that is called as chassis earthing. The figure continued in 2011. There is no need of earth electrode in soil because this concept is called as foundation embedded earth electrode. It works very well. You can see here serial number 21, foundation earth means the steel which is inside the concrete does the job of earth electrode, and this is the correct method. This is the safest method for a hospital. Similarly, for the operation theater, a mandatory safety measure is supplementary equipotential bonding, means you must bond again. Additionally, you must bond all the metal parts inside the group 1 and group 2 location so that the patient is not getting a shock. There is no chance of arcing, there is no chance of fire, and so on. Now, sometimes biomedical equipment require individual earth. Sometimes the manufacturer say this as dedicated earth. Now, in the picture at the top, this is dedicated earth, means you have an operation theater, you have to have a common bus bar. Each of the equipment must be connected through with a dedicated wire. Separate connections are required, and this is called as individually earthed. Now, on the bottom, you can see earthed in group. The problem is in an individually earthed system, if there is a problem, if there is a leakage in equipment number 4, it do not influence equipment number 1, 2, 3. Whereas in case of a group earthed equipment, a fault in equipment number 4 will create or will influence equipment number 1 and 2. In order to avoid that, individually earthed systems are required, and the maximum resistance between the MET, common bus bar, and the individually earthed systems are also specified in the standard. Please note that earthing has nothing to do with the earth pit, plate, pipe in the system. One important safety measure which has to be implemented in every hospital is the maximum allowed disconnection time. In a faulty equipment, before the faulty equipment creates a shock or before the faulty equipment ignites fire, the supply has to be disconnected within specified time, Tn 0.2 seconds, TT 0.2 seconds. There is a small mistake. This is 0.4. But for medical location, group 1 and group 2, the disconnection time is 0.2. Means within 200 milliseconds, the protective device should work and it should trip the supply. 50 volt is the allowed shock voltage during fault in group 0 location, and 25 volt is the allowed shock voltage in the group 2 location. Please note that the working voltage of an electrical equipment is 230 volt, but we must make bonding equipotential bonding in such a way that the maximum allowed voltage is 25 volt in group 1 and group 2 locations. As I said, one of the most important safety measure is called as efficiency of automatic disconnection of supply. There must be a protective device. As you can see here, this is a protective device. This protective device must trip within the time in case of a fault on the circuit, fault on the conductor, or fault on the equipment. The device must trip. How does this trip? Again, very well explained in the standard. You are supposed to make a TNS system. Means as you can see in the single line diagram, there is a source, there is a line, the neutral returns back. Body of the equipment is connected back to the neutral of the transformer through a metallic conductor. This is called as TNS system. Whenever there is a fault in your equipment, the fault goes through this closed loop. Now the impedance of the loop comes into picture, and this is called as fault loop impedance. The CEA regulation as well as the NEC had emphasized this subject very much. And ideally, in a hospital, fault loop impedance shall be calculated during design, and it has to be tested during erection and verification. This is just to ensure that in case of a problem, your supply is disconnected in order to make the area safe. There is no fire. That is the job. Medical IT system. Medical IT system is a very special power supply system for Group 2 medical location. Group 2 is a medical location with which the life of the patient is because of the medical electrical equipment. Any disconnection of the power supply to the medical electrical equipment will be fatal to the patient. The patient may die. So, and sometime multiple devices are connected to the patient. Sometimes 3, 4, 5, 6 equipment are used in this particular area. Imagine you have 6 equipment connected to the patient body or used somewhere nearby, and the seventh equipment is a faulty equipment. As soon as you put the faulty equipment, if the supply MCB trips, that's it. You will be in deep trouble. In order to avoid such problems, medical IT systems are mandatorily or made mandatory in Group 2 locations in the National Electrical Code of India. These are special electrical supply, probably from an UPS, but there is the power supply is from an UPS, but there should be an isolation transformer of maximum 10 kVA capacity, which is feeding to multiple small biomedical equipment. The equipment, this is just an example. There is a transformer, there is a measurement of the temperature and overcurrent of the transformer, insulation monitors are there, fault locators are there, displayed systems are there, warning systems are there. Finally, it looks like a panel what is shown in this particular picture. Medical IT system consists of medical isolation transformer as per this particular standard, medical insulation monitoring system as per 615578, medical fault locator 615579, P conductor disconnection monitoring, because one of the biggest challenge in India is there is no earth wire sometime. Now this will monitor display and communication panels and the alarm transfer unit and BMS transfer to BMS. So basically, this is an automated system which tells you that in a Group 2 location, even if there is a faulty equipment, the system need not have to trip. The power supply can continue and the patient is in a safer situation. And the Group 2 medical IT system in Group 2 locations are a mandatory requirement. Supplementary equipotential bonding in Group 1 and Group 2 locations are a mandatory requirement. Similarly, electrostatic charge. Electrostatic charge has been accumulated by friction of various parts, probably the dress of the medical practitioner or the medical staff. This can create electrostatic charge, and if the charge is discharged to the equipment or to the patient's body, this is fatal. The IS standards recommended electrostatic charge controls such as earthing of personal via footwear and flooring, earth other conductors where flooring or direct connection. So different methods are recommended, and in Group 2 location they are required. Group 1 location there are some recommendations. So ideally these measures are to be implemented. Electrostatic charge control in the biomedical equipment, which is the responsibility of the equipment manufacturer. And if the equipment is tested as per the standards, then of course it is already taken care by the equipment. The electrostatic charges in the locations categorized as AP or APG. That means the area where, with a large amount of explosive gases are present, they are already taken care by the equipment manufacturer. One more subject which is to be followed mandatory is inspection of the electrical installation. Initial verification, I put in bracket, means before you start using the electrical installation, that means in a new electrical installation or a newly made part of the electrical installation, inspection is mandatory. There are 17 subjects for inspection, starting with the methods of protection, against electric shock and so on. There is a lot of subject to be inspected. There are several subjects to be tested during the initial, before using the appliance. You are supposed to conduct, let's say, serial number 1 to 10 test. starting with the resistance of conductors, insulation resistance. You see number 6, effectiveness of automatic disconnection of supply, and so on. All these tests are made mandatory. There are formats provided in the standard. You must fill up the format. Once when you carry out the test, you can identify the defect, and the contractor must rectify the defect and put the supply in such a way that before using the electricity, you are sure that you have a perfect electrical installation. Then you have to maintain it and you have to do periodic verification. The National Electrical Code gave some tables where the recommended years between periodic verification are being included. Periodic verification is very much necessary in medical location, especially for some additional requirement, not in a normal building, in hospitals. Something more is required. Example, functional testing of changeover device should be made every 12 months, because if this device is not working, you are in deep trouble. Functional testing of medical IMD, insulation monitoring device, and the overloading and the current of the medical IT transformer has to be measured. Measurement verifying the supplementary equipotential bonding every 36 months. Main equipotential bonding again 36 months. Functional testing of electric supply for safety services for firefighting, for example. The batteries are to be tested with the minimum 15 minutes capacity test. UPS and combustible engines at least 80% of the rated power. Combustion engines 60 minutes you should do these particular tests. Annual functional test, and UPS and combustion engine at least 80% of the rated power. So I'm not going to read this. So these additional safety measures, if you do it periodically, you are sure that the changeover switch is in a good condition, so that in emergency you are not under risk. The backup electrical supply source such as UPS and the DGs are in a good condition. They are efficient. They are ready to cold start. They are ready to work for whatever the time which is required. So all these periodically you must ensure. The biomedical equipment which you are using are also to be tested as per the standard 62353. These instruments which I am showing on the left, this is an instrument which can be used for testing the biomedical equipment. Ideally, every hospital, the biomedical engineer should have this kind of a test instrument, and he has to test and ensure that the instrument, the biomedical equipment are in a good condition. Now, when it comes to the hospital, first of all, we should keep some things in our mind. Hospital is a hub of electrical installation. So many electrical items are there. You cannot really count. Without electricity, you cannot really run, or you cannot even think of a medical location. You cannot think of a hospital. The challenge here is, once started, stopping may not be possible. That means you started running the hospital, patients are coming, patients are there in the critical location. For some reason, if you wanted to stop the power supply to the hospital or to a particular location, forget it. It's not possible. As a result, you must make the electrical installation the highest reliability what is possible, the highest reliable electrical installation shall be made. You should no compromise. There should not be any compromise to the engineering practices accepted in the National Electrical Code. So if NEC had published certain things, of course, you must follow it very carefully. So please keep in mind, once started, stopping may not be possible. I have been doing supporting some of the hospital chains, some of the hospitals for carrying out some work or some critical work, some advices. But it is extremely difficult to switch off the supply. Sometimes we may have to wait for Sunday evening 6 o'clock, Sunday evening 8 o'clock. Then we get maybe 2 hours to switch off, and the entire study within these 2 hours may not be possible. So please keep in mind, you have to take electrical installation seriously, and you should make the installation highly reliable. When designing an electrical installation, the National Electrical Code says, I put this as a challenge in design. I just put the example of designing the conductor, design requirements of the protective device. Normally, the designers of a new hospital, example, when we ask, how did you selected this wire? Then they say, depending upon the voltage drop. Not only voltage drop, there are so many parameters to be considered while selecting the conductor. Circuit length, earth fault loop impedance, impedance of live conductors, voltage drop is one of the parameter. Considering only voltage drop and selecting a conductor was the practice during 1970s. Now we are in 2025. All these parameters for selecting the conductors are required. All these parameters for selecting the protective device is required. Normally, protective devices are selected based on the load and short circuit current. The other parameters are mostly ignored. That's why I put this as a challenge. We are not in 1970s, we are in 2025. Please ensure that the designer is making a design in a hospital considering all these parameters. Otherwise, your installation will not be efficient. It will not be reliable. The standard made several recommendations. One such recommendation is to avoid explosion. You can see here electrical devices and the gas must be minimum 200 millimeters away. The physical distance should be minimum 200, at least 200 mm separation distance is required between these two. Medical gas outlet for oxidizing or flammable gases shall be located at a distance at least 200 mm from the outlet to minimize the risk of ignition of flammable gases. But most often when we visit a hospital, what we see is this minimum 200 has been misunderstood as maximum 200. Most of the cases, the distance is much lower than 200 mm. Please make it very clear that the minimum distance between the electrical sockets and the outlets for gases is 200 millimeter. You make it 300 or 400, which is much more safer. One fashionable requirement demanded by the electrical biomedical engineers and sometimes also by the electrical inspectorates in some of the states, not all the states, is to have separate earth electrode, separate for neutral, separate for body, separate for equipment, and so on. Please note that earthing has nothing to do with earth electrode. Earthing is about interconnecting all the metal parts in such a way that there is no shock exist. So in the standard, this cross mark is given to tell users that please don't use it. The challenge which we see in most of the hospitals are there are hundreds of earth electrodes, 50 to 100 earth electrodes, and there is no equipotential bonding, which is a violation of the fundamental electrical safety measure. The biomedical equipment manufacturers are always demanding 1 ohm or 2 ohm earth electrode. And then they say you use chemicals or you put water into the earth electrode in order to achieve this resistance, which is absolutely wrong. This is a big mistake. And no efficient automatic disconnection is ensured. Efficiency of automatic disconnection means the tripping time of the device and how efficient are the device able to trip is a very important safety measure, which is very, very rarely ensured in the hospital. Recently, I saw a hospital electrical safety audit. The auditor went around the hospital and he was measuring the voltage and current of each of the panel. Then measured the earth pit resistance and made a thermography and gave to the hospital management saying that your hospital is safe. Then once when the management told me, look, this is my electrical safety audit report, what is your opinion? I replied to them that whatever written, voltage, current, earth pit resistance and thermography, all these are not related to electrical safety. So this is wrong. Biomedical equipment manufacturers asking for separate earth pit. To some extent, this can be thought as a, they are not reading or the competency is little bit less. But recently I saw one very interesting electrical requirement from a supplier of the cath lab, as you can see, cath lab. The electrical requirement. Serial number 4. Facility should provide 6 numbers of dedicated earthing as per our drawing. Means dedicated earth pit. This is okay. We can educate them and we can change their mind. Please note that this 6 number of dedicated earth, it's big mistake. These earth electrodes are going to endanger your equipment as well as the patient and the doctors. UPS neutral earth must be placed 5-meter distance from other earthing. Cath lab earthing should be 5-meter radius. Other body earthings are not allowed. Serial number 7 was the most funny part. There is a practice that some hospitals put continuously water into the earth pit in order to maintain less than 1 ohm, because if you don't maintain less than 1 ohm or 2 ohm, the equipment manufacturer will not give guarantee. So now this equipment manufacturer made an interesting subject. If water trench provided for earthing, neutral earthing water provision should be separate. That means you should bring water for the cath lab is from your hospital. Water for the neutral earth electrode should come from another panchayat. You see, these are really, sorry to use the word, these are really idiotic electrical installation practices. These are not at all scientific, and these are the reasons for accidents most of the time. Please stop using this. This particular equipment, as I shown you, electrical installation, TNS system. Now the line impedances are very much known. But what happens is, this equipment is suitable for TNS. This means the fuse inbuilt into this device is capable of automatic disconnection in case of a line to line, line to neutral, or line to earth fault, because you have to keep the impedance lesser than this value. So the fuse inside the equipment is efficient to disconnect in case of a fault. Unfortunately, what we do is, we, instead of TNS, this medical electrical equipment is connected to TT or IT system, and the danger starts there. If an equipment designed for TNS is used in TT or IT system, you forget. Equipment may work for several years, but once when there is a fault, you will be in disaster. Please don't do it. Another challenge which we face is a biomedical equipment manufacturer coming with an argument of neutral to earth voltage. 2 volt or 3 volt or 5 volt, more than 2, 3 volt between neutral conductor and earth conductor, they say, my equipment fails, which is absolutely wrong. I'm showing you from the standard. Every class 1 biomedical equipment are capable of working 90% to 110% of the rated voltage continuously. You see here last, between any of these conductors and earth. Any of these live conductor means between line to earth, 110, 230 plus 110 means 253 volt. Line to earth voltage 253, neutral to earth voltage 253 continuously. Still the equipment is capable of working, and this is a mandatory testing in the equipment standard. 2 volt, 5 volt, 10 volt for a class 1 biomedical equipment is absolutely of no use. These demands by electrical biomedical equipment manufacturers are made because, first of all, probably they don't know the subject. Most often they don't know why the equipment is failing. The equipments may be failing because there is one more parameter you see here at the top. Over voltage category 2 for mains transients specified by the manufacturer is required. It is the responsibility of the owner of the hospital to ensure that the mains resistance, the installation category is maintained. So it is not the voltage, it is the categorization, and maintaining the categorization will protect your equipment. Now there is a misuse of recommendation. Recently, I saw this. There is, a cath lab supplier. They are asking from here. You can see serial number 7 onwards. They are asking to put a medical IT system for a cath lab. Absolutely, this is wrong. Medical IT systems are possible maximum up to 10 kiloampere. The maximum leakage current has to be limited to 0.5 milliampere. So this is wrong. This is a misuse of the recommendation by the manufacturer. Another misuse is UPS with isolation transformers are being called as medical IT. This is wrong. Please download the standard and use the standard. All these recommendations are very much included. Now, Lakshmi, am I audible?
Yes, sir. Yes, sir. You're audible very much.
Okay. Okay. Because I got some phone calls and I thought in between probably there is a
No, no.
disconnection.
You are very, very clear.
Okay. Thank you. Now, challenges, confusion created by authority. A lot of hospitals nowadays are NABL accredited. Unfortunately, the last edition of NABL has included one line. The help of new technology like thermal imaging can detect loose connections in the system and thereby prevent a fire incident. Thermal imaging or thermography is not recognized as an electrical safety measure at all. Thermography is not recognized as an electrical safety measure. There is a series of verification which is required. A compliant electrical installation is not supposed to have loose contacts and hotspots is the correct way. Your entire electrical installation is not supposed to have a loose contact. You forget about loose contact. Now what we do is you make a unreliable installation with a lot of loose contact, then try to find out where the loose contact is. This is not the correct way. Similarly, one of the biggest confusion in the electrical installation is created by the electrical inspectors. Electrical inspectorate or the electrical inspectors are creating a lot of confusion in the country. Their responsibility is, is to keep the installation safe. Instead, they demand separate earth pit for neutral, separate earth pit for body, and make a mess out of this. I would like to thank Tamil Nadu Electrical Inspectorate. They are the only electrical inspectorate where I have seen they are writing circulars to every hospital whenever the hospital go for the periodic validation of their license. The inspectorate is issuing certificate, issuing letters and asking them that the National Electrical Code has got all these technical requirements and you try to comply to this, and they are demanding to issue compliance. So I would recommend that if anybody listening from other states, other than Tamil Nadu, as I said, I thank Tamil Nadu Electrical Inspectorate because they are doing a good job. Other electrical inspectorates also should start doing this. Videos like this, live fire in medical locations, these are quite common in YouTube now. Probably the last, the last video of the fire accident. Also, probably very soon we will see the video what has happened. On the left side, what you are seeing is a biomedical equipment. Live, it is catching fire, and a lot of patients are still there in the room. The second one on the right side is an air conditioner fire which killed 17 patients in a Virar hospital. Please note that fire due to short circuit is due to non-compliance of regulation and standard. It is not because short circuit is not supposed to create fire. In case of a short circuit, much before the short circuit create a fire, the protective device is supposed to trip the supply. Fire due to short circuit is due to non-disconnection of the supply. That means your protective devices are not efficient. We have the Electricity Act 2003. Section 146 to 151 of the Electricity Act says, if you have an unsafe situation, what is unsafe situation? Your MCBs are unable to trip. You are having, let us say, one hospital caught fire. The reason is short circuit. Why the short circuit? Because your installation is not in compliance with the standard. In such a case, the owner, the proprietor, the managing director or general manager of the company or the hospital can be punished with 3 months imprisonment and 1 lakh fine plus 5,000 rupees fine per day. There is a provision in the Electricity Act. So if there is an accident, of course, there is a challenge. Please be careful about this. How to improve? The first one which I recommend is, first is you classify your medical location and create a list of medical locations. make a detailed study. This is for the existing hospital. Make a detailed study of the existing electrical installation. Sometime it may take a few weeks to months. I have been doing one of the studies. Then finally, it took almost 3-4 months to identify the entire electrical installation in a large hospital. Conduct essential test and identify the risk. Create an improvement plan and discuss with the management. The improvement plan consists of sometime creation of single line diagrams, explosion and fire propagation control measures, touch voltage reduction measures, efficiency of automatic disconnection, electrostatic charge control, medical IT, plan for periodic verification. All these are the improvement plan, parts of improvement plan. Then training for the electrical and biomedical engineers, discuss with biomedical suppliers and finalize the improvement plan. Implement the improvement plan through the existing staff, the electrical and biomedical engineers. This is the plan which we are following up, which we are making in several hospitals. Unfortunately, when we make the study, the results are really alarming. In a new hospital, create an electrical distribution strategy, classify medical locations and create a list of medical locations, support the electrical designer to comply the NEC. I have shown two lists of how to select the conductors, how to select the protective devices. These must be carried out by the electrical designer, and probably if the electrical designer do not knows this, we can help them. Train the electrical and biomedical engineer, discuss with biomedical suppliers and train them on the modern safety requirement. Carry out comprehensive initial verification, means complete inspection and test, identify the mistakes and support to rectify. Prepare the initial verification report, prepare periodic verification plan and maintenance plan. These are the steps which generally I propose in hospital. For a new hospital, there can be a plan for the existing hospital as well. With this, let me stop my presentation. Thank you very much for listening. We can, as I put here, we can help you to improve. If you have any challenges, of course, every hospital has got an electrical challenge. You can write to us. We can visit you. We can help you in improving. Thank you very much, and over to Mr. Dominic.
Thank you, Mr. Gopakumar. Lakshmi, please mention his mail ID on the chat box. President, both personal mail ID and also NFE's mail ID. So it will be of much use to the audience to take a note of that. So I will just tell you a little bit of what system, how are we monitoring. It's very important for the hospitals to monitor the entire fire system 24/7. Today, as the technology has improved so much and every hospital is connected with internet, you can monitor the entire fire system 24/7 with very simple. You have two options. Whether you risk the category losses if the alarm never checked. Many times, if you look at the Jaipur incident, the report says fire detection system never worked, and some are claiming that sprinkler did not work. Now, the legal system is such that the entire management will be held responsible for not maintaining the fire system. If you look at most of the cases, whether a MRI hospital, entire management is behind bar. It is non-bailable offense if you're not maintaining the fire system as per the NBC. So there are systems which you can monitor 24/7. I put up a small diagram here, how these system can monitor. You have an individual pump, all jockey, master pump, diesel pump can be connected through sensor. Hydrant pressure can be checked. Hydrant and sprinkler leakage. If there's a leakage on the pipeline or the sprinkler, that can be reported. Pump normally always supposed to be on auto mode, but the control panel, because of the maintenance, they turn off and put it on manual, but they forget to put it on auto mode. Those things also can be monitored. Then we have fire in a tank. many of the situation, the most expensive apartments which I've seen, they don't maintain enough water for the firefighting. Whenever the water level is down, you can get an alert. There's no water in the sump or the overhead or the storage for the firefighting, and you can monitor the fire panel, that is fire detection panel. Whenever it goes on alarm condition or falls, you get an alert. Your PA system and your ventilation system, smoke management system can be monitored. All truth can be monitored through a simple your app-based software or the dashboard, which can give you alert. Not only that, this particular app can monitor the entire diesel generator monitoring, HVAC monitoring, gas monitoring, and all that. So I wanted to say that when technology is available so much and informations are available, why we are not able to implement this? Because we always say there is no return of investment on safety. This is the biggest argument that we get. We do not have budget, or management did not reserve the fund for maintenance. Most of the accident happens where we do not maintain the system. With this, I want to conclude. We are here as a NFE experts. We have a wonderful members there who are qualified fire verifier, and we have Mr. Appavu sir, who was retired electrical inspector of Tamil Nadu, who's been training electrical engineers, and also we have a certification program on verifier. So we have so many, knowledge available, information available, certification courses are available. I would urge everyone who participated, become a member of NFE and access to all the webinars. When I said 180 webinar we concluded, all these are available in our website, and these are accessible only to the members. So I will take up if you have any questions, and we will take Q&A. Please post only into Q&A. Your chat box will not be useful for us to take and keep record of your questions. So I will ask our president and also our Appavu sir. Sir, Appavu sir, you raised your hand. You want to say something? Please go ahead, sir.
Yes, thank you, Mr. Dominic ji. It's a very good, enthralling session conducted by Gopaji in a clear manner. No doubt, we have internationally equivalent standards. We have technical standards in our country which are freely downloadable through BAS WebCare, whether it is a medical equipment standards under IS 13450 or electrical installation medical location IS 17512 and section 9 of NEC specifies the requirement for medical installations. So these are all available in plenty. It's also available, valuable documents equivalent of IECs are downloadable, free of cost. But what is the missing link? We have enough standards and enough regulations put in place. Mr. GK has already explained what IE Act says and what NABH guideline says and what NEC says. But there is a missing link, I can say. What is that missing link that we have to analyze? If there is a strong kick, there can't be a carrot in saving lives. For example, ROI analysis and payback analysis can't be there. It's a precious life. So unless the stick is taken hand by the implementer, it can't happen. What is the missing link then? The NABS guideline clearly provides responsibilities of management through ROM, Chapter 7. It also provides a clear cut FMS, that is management responsibility, facility management services. It provides several core components to be compliant. But when a common man, say like an electrical engineer and the biomedical engineer, see these documents, and who is the person going to be giving accreditation, they can't follow unless there is an assistance from the external body to decipher. Actually, the deciphering the standards is missing. Our NFE is doing something. This is not enough. There is a big gap between the biomedical engineer and the electrical engineer within the organization itself. They don't have interactions. Similarly, whatever the audit reports that is going to be presented for NABL accreditation are in papers only. That I don't know how it is being monitored and how every hospital is being accredited is to be analyzed, because the FMS itself is not saying specific things on how to comply. It just puts valuable recommendations, no doubt. How to make sure what are all the documents required? They can be specific. You have to comply with these such and such documents. For example, you have to get the audit report as per NEC Section 9, or medical equipment standard as per IS 13450, or electrical installation of medical equipment as per 17512. If these are not complied, then the accreditation should not happen. So this is the thing. This is the final thing. Once the reports available are given by the auditors or the biomedical engineers and the management electrical engineers, then if it is not scrutinized properly, whether it can be an electrical inspectorate or the accreditation body, if it is not scrutinized with an external available technical experts, it can't be a good implementation. Once we start implement these things clearly, it's not in letter and spirit. Only letter is available, spirit is missing. If you add the spirit also to this letter, then every hospital will become a safe environment. Until such time, we can't assure, sorry to say, we can't assure any hospital environment to become a really safe place for patient as well as the public, as well as the visitors, including the working doctors. It is a very pathetic situation prevailing in our country. We have to concentrate in such area where accreditation is given, where how the documents are relied upon, who is preparing these documents. These areas should be made accountable, and the institution at large should be kept safe to the people. This is my opinion, Mr. Damiji.
Thank you, sir. Thank you for valuable comments, sir, with your expertise and so many experience, over 40 years of experience. I'm sure these comments are very, very valuable. Sir, we have, people have raised this question. After 10 questions, we will go to people who will, raise your question. I will unmute you, then you can speak. But before that, I would like Gop Kumar to take up this question. Sir, I think the very, very interesting question from Guha.
Yeah, in an existing hospital with multiple earthings already set up, 2 for transformer N, 2 for TX body, means transformer body, 2 for DG, 2 for DG body, X-ray 5 numbers, CT scan 5 numbers, cath lab 6. So totally say 60 earth pits. TX and neutral grounding and 3.5 core aluminum cable panel are provided. 4 pits are present which run along the electrical shaft. 2 core cable have connected. Now when I am conducting an electrical audit, should I refrain from measuring individual earth pit resistance? Should I go ahead with only fault loop impedance test? If yes, in such complex earth system for a 9-story hospital, no equipotential bonding is, how can I conduct fault loop impedance? So, Mr. Guha, the simple answer is this hospital is absolutely not in a safe condition, because 50, 60 earth pits and you are doing an electrical safety audit. It is better not to do an electrical safety audit, because your electrical safety audit itself is not going to produce any result. It is not only about fault loop impedance. What about all the other safety measures which we discussed? So better advise the hospital that first you change this entire system according to the standard, then you make a safety audit. That is the simple answer which I wanted to give. Dominic sir, can you go to the next question?
Yeah, second, Chandresh Parekh. Sir, can we use putty pad and instrumentation paint inside the panel and pass? Yeah, this is a quite common one. Yes, you can do that. Now we have passive painting coatings are available that you can use. That's only protect the body of the panel. So Mr. Rao, S.R. Rao is asking, is there any statutory body which verifies all the points that you mentioned in this webinar for hospital? Is there any statutory body is monitoring?
So, Mr. S.R. Rao is asking, is there any statutory body which verifies all points mentioned in the webinar for hospitals? Unfortunately, no, Mr. Rao. There is no body in the country which is verifying all these measures, and that is the reason for all these accidents. Because the electrical inspectorate's responsibility is up to the point of commencement of supply or above the notified voltage, and something little bit things inside the hospital. But as I said, the Tamil Nadu Electrical Inspectorate now started enforcing, because the Central Electricity Authority regulation demand compliance to NEC. So the Tamil Nadu Electrical Inspectorate started demanding, which is a good move. Probably this will bring improvements. But what about the other states? Especially Maharashtra and the UP and the states which has got a large number of population and a huge number of hospitals. So everywhere this implementation should happen. So a question from Mr. Amritalal: it's easy to educate about the importance of one than a biomedical engineer. I don't know whether it's a question or answer or a statement. So can you repeat the conductor selection and earthing selection? Is a question from Mr. Bapat. Mr. Bapat, please.
Sir, we have lost you. And there's no audio. There's no audio video. One second, please. Let me see. I think he lost his internet on this.
Mr. Dominic, I would like to say
Yeah,
the
you
answer
answer
for
the question, sir.
Yes. Sir, regarding conductor selection and fault protection devices, there are several videos in our NFE website itself. It's a very 1 hour, 2 hour subject. How it is complied as per IS 732 is already there. Please go through, visit our website and see that those compliances are met. The compliances are basically basic protection and automatic disconnection for fault. That is whether it is short circuit or earth fault. So there are several aspects, and what should be the sizing of conductor depending upon the short circuit rating as well as the design current rating, and whether it can withstand the fault for a certain time, and whether the disconnective overcurrent protective devices can operate within the specified time that Mr. GK has already explained. For example, if we have a 6 amps B type MCB, then at the 5 times the rating, that is 30 amps, you should trip. And your circuit should have a fault loop impedance accordingly. So that is 240 divided by these 30 amps will be some value of ohms. You have to assign a factor 2/3. So the automatic disconnection is an important point. So these are the things that I can explain. For further details, you can go through the standards as well as our NF YouTube videos. That's all. Thank you.
Sorry. Yes, sir. We lost you in between.
There is a problem. Suddenly my internet connection got disconnected. I don't know why.
So Appa sir answered. Geeta is asking, please share the electrical safety checklist. If you go to our website, we have a guidelines for hospitals. There is a hospital guide, electrical guide for a hospital, and these are available only for members. So those who can just able to spare 1,000 rupees a year, and you can access to all this information through our website. So Geeta, it is available on our website. You can download subject to your member. And Pallavi, can you create audit checklist? It is also available in our website in chargeable basis. Of course, We can share anybody coming forward for asking for verification. We can share it to those members in the respective region. That we are able to identify exact cause of fire in Jaipur incident. Unfortunately, Mr. Amit Kakkar is just logged off. He was the one who did, is our regional director of NFE and also the, very responsible government servant. He did the first-hand report of the incident. So exact cause we will get to know very soon. If he was here, probably I would have taken him on the call, and he just logged out. I will get you this information a little later. Sanjeev Kumar, question to Gopakumar sir. Can you conduct a webinar on real case studies, one of the hospital which you mentioned regarding inspection and measures suggested?
But it is not good. You see, I am doing this. One moment, sir. Yeah. I'm doing this study in multiple hospitals, and it is not good to share the information from one hospital to the other. It's not ethics, so I cannot do. But if you have a hospital, probably we can make a study of your hospital, and if you are ready to publish it, we can publish.
So Dr. Rajusha is saying NABH should be asked to include all these requirements and review and revise the clauses. He was appreciating our presentation, but if you can, NABH can insist that this checklist is implemented. Good suggestion. We can write to NABH and recommend, sir.
Yeah, we tried this multiple times, but when it comes to electrical installation, there is a scarcity of expertise. People go with the assumptions and they think that some partial information which is available, like this thermography. It was a big mistake by the experts in that group to write, thermography will detect loose contact. First of all, an electrical installation should not have a loose contact. So, but the best way is if there is a question like a government authority or these bodies, they can write to BIS. BIS have got an expert committee, and the committee members can support them.
True,
of course, we can. NFE also can do this.
Sir, Sunil Kumar VK is asking, without connecting the structural earth to the ground, how to control the touch potential limit during a fault?
Without connecting the... I cannot see the question because in between I got disconnected. So all these old questions are gone.
The first
question is...
Without connecting the structural earth to the ground, how to control the touch potential limit during a fault?
You can make use of foundation earth electrode. The concept is global earthing system. If you have your own transformer, you can go to ISIC 61936 part 1, where the subject is explained. It's called as global earthing system. That means all conductive parts must be bonded in such a way that there is no touch voltage exist. So
Ashit is asking, and I think there's a lot of interest in this. Please clarify the separate earthing for biomedical equipment once more.
You see, separate earthing. First of all, the definition of earthing is you have a common earth bus bar in your room and connecting the equipment to the common. I will just show from the IEV online. Give me a second. Let me connect that. The easiest method is what you are seeing in the screen is the International Electrotechnical Vocabulary. This is the free vocabulary published by ISO, IEC, and BIS, all these standards making bodies. Now here, the meaning of earth. The meaning of earth is earth, part of earth that is in electric contact. Sorry, that is local earth. Earth, verb. Earth means to make an electric connection between conductive part and local earth. Means you take a wire and connect two items. One is a conductive part, one is a local earth. That is earth. Now, what is this local earth? Part of earth that is in electric contact with an earth electrode and has an electric potential, not necessarily zero. So, and the process of making this connection is called as earthing. Now, I have shown one of the pictures. Let me take that picture. So, sorry. I'm sure you are able to see the screen. Now, on the top where I am moving the cursor, this is called as individually dedicated earth. For example, individually earthed system means each of the equipment must be connected to the common earth bus bar in the room separately. And bottom is connected in group. Biomedical equipment, sometime, most often, you cannot earth in groups. You have to individually earth. Hope it's clear. You can find this picture in the standards as well. So the next question.
The Vimal is asking, okay, share the link to joining in. Okay, Ms. Sami. Lakshmi, please ensure that in the chat box, give the link to people, or a lot of people are asking how to join NFE. Please make sure that the link is given. Sunil Kumar is asking how the isolated power system design for power system reliability is critical areas. How the isolated power system design for power system reliability in critical areas. So can you understand this question, sir?
Yeah, how the isolated power, the requirement of isolated power systems or power supply, it's not a power system. It is a power supply, isolated supply for a small area. You cannot make an isolated power supply for a large area for the entire hospital. You forget about it. For the medical group location, group 2 location, you can make it. It's explained in the standard. I would request you please download the standard and go to that section. It's very clearly written.
There's a Nazareth Hospital. Sir, how can we check the line impedance?
Again, look at the NEC part 1 section 18, very well explained how to test, how to, or IS 732, very well explained how to measure, how to calculate, how to test. There is a new standard IS 3043, which is upcoming, probably it will be published very soon. In that standard, we have put with pictures for easy understanding.
See, for those who are asking about this standard, it is available freely downloadable from BIS Care. So India is the only country sharing the standard free of cost. So you have to register in BIS. If there is an app called BIS Care, go there and please download the NEC National Code of India. Standards are downloadable free of cost. So I'm moving on to Gopal Singh Yadav. We have installed Cummins make 250 kVA DG set in our 132 kV substation for auxiliary supply. What is stack monitoring guideline? It should be more building. Sir, can you read this question? Probably I'm not able to understand.
I can't see the question. I can't see the question because I disconnected in between. I can see the questions only after that.
I'll call you back. Do you want me to read again?
Yes.
Gopal is saying we have installed Cummins make 250 kVA DG set in our 132 kV substation for auxiliary supply. What is stack monitoring guideline?
No, I'm not clear. We have a 250 kVA transformer. What was the next part?
We have a 250 kVA DG set, 250 kVA DG set in our 132 kV substation for auxiliary power. What is stack monitoring guideline? Is it to be? It should be more building. I don't know. The question is not very clear. However,
Also, our subject is not about the substation. Our subject is specific to the hospital. So no hospital will have a 132 kV substation.
Sir, can you read this question? Are you able to Balakrishnan HVAC system, MRI scan, cath lab, earth value 1 to 2 mega homes, or is it or is it okay or not?
Mega home or home?
MG homes.
Mega ohm, that is the insulation resistance. Of course, the minimum insulation resistance is 1 mega ohm. If the value is anything above 1 mega ohm, absolutely your equipment is in a good shape, good condition.
So, like the hospital, can we connect the DG neutral DG body to a common earth bulb?
Yeah, that is the way. There should be a common bus bar. In the hospital, you are supposed to make a TNS system for general supplies, and if you connect the HT side, neutral, and all the equipment to the common bus bar, not only you achieve efficient automatic disconnection and equipotentiality, you will also achieve the transfer potential problems. So you can make much more safer installation.
Yeah, Sriram Menon, you're asking, can I access to details if I'm an individual member? Just our website membership. Yes, of course, if you're a member, you can access to the. If you have any difficulty, we'll connect you. Lakshmi, can you please mention the email ID of our membership support? So if any challenges are there for them to access, we can take it forward. Please, in the chat box, please mention the email ID.
Regarding the biomedical equipment, somebody was asking what do we do with the biomedical equipment? The biomedical equipment need to be the PAT, portable appliance test, or there is an instrument which has to be used, and the calibration and the testing of all biomedical equipments are possible now. You have to do this test according to the periodicity recommended by the manufacturer.
Sir, Vijay Mohan is online. Can you can go on live with Mr. Gopakumar, Mr. Vijay? Yeah, please go ahead. Vijay Mohan, can you hear me?
I
Vijay
think
Mohan?
probably no. His mic is on, but probably there is some problem.
Okay, whenever you're able to speak, you're unmute. Whenever unmute, please go ahead and talk. I'll take the question from Anita D'Souza. Is a certificate issued for the participant? No, it's just a knowledge series. So we have various other programs in which we issue a certificate, but we can say you attended the webinar. In case that helps you, we can always you can write to me. There is the email ID.
Dominic sir, I can see an interesting question from Mr. Vinayak Apte. For solar PV system or for lightning system, if separate earthing is created, is it as per the standard? If there are more than 50 earth bit for transformer body and for DG, is it as per the standard 50 earth bit? Sorry, it is not as per the standard. Very simple answer.
Okay.
Sorry, it's not as per the standard. No standards are recommending to put separate earth bit. In fact, the standards had asked not to do it.
So we have a Dr. S.P. Anchuri, who is also the president of Hyderabad chapter of Focus. So he's asking the question, the challenge in mixed-use building where hospital also running in few floor and mainly the cellar and the basement converted into labs. How they can be tackled for fire safety? Sir, as per the standard, you cannot have basement for the lab. We have to see Hyderabad, Telangana is supposed to be one of the most effective fire department. We can take, I think there are a few people from Hyderabad fire department also there. I will connect you with Anchuri sir. I will connect you and discuss with you. Yes, you're right. Mixed use complexes are plenty. There are nursing home with 50 bed. There are hospital with 70 bed, where mall also occupy there. There are resident also located in the same building. It's a very big challenge. This is the only country where hospitals, the building are not meant to be for hospital, but over the period, the hostel become hospital or the hotel become, when there is a loss of business, they convert into hospital. hospital structure itself is completely different. Today, that's the beauty of this country. Anybody can become a hospital owner if they have 150 rooms. So
Actually,
yes,
my view in this particular subject is we should understand about our population and our demand. If we try to think that all hospitals should be as per the standard rules and regulations, probably sometime it may not work out. So sometime, a building meant for other application may be converting and using it as a hospital. To some extent, there is a demand, it should work. But while converting, if the safety measures are not taken care, then you are in risk. So you can probably convert if the authorities are allowing, but ensure that more than that, you make that installation safer for people and property and the medical staff. That is all about our today's program.
Vijay Mohan, you want to talk? Pallavi, you want to say something? Vijay Mohan, we are there
Hi,
still.
hi, Dominic Gopaji. Actually, can you hear me, sir?
Yes.
Yeah,
Yeah. We have connected to more of electrical engineers. So for this particular hospital per se, can we connect to Biomedical Engineering Society of India, and where we can, have these biomedical engineers, and where we can have the same session for them. Just a suggestion.
yeah, of course. Why not? You set up that meeting and check with our dates whether we are available. We can do a program for them, biomedical engineers.
Thanks.
Thank you, Ms. Pallavi.
Thank you. It is almost 2 hours. I think Gopakumar not slept for for the whole night and day. It's unfair for me to make him continue this session. Learning is never ending, and we wanted to always stick to 1 hour of webinar, but the kind of question which is coming, sometimes very funny, sometimes good, sometimes we feel how ignorant we are when the such questions also asked. But we continue to be a member of NFE. I'm sure this perception, this information also help you to become more what we call electrical professional. So we'll come back. We have next week again, Saturday, Mr. Gopakumar is coming and talking about electrical installation with the foreigner who is an international speaker. Very interesting subject. So I'm sure you all will join for the next week, same time, webinar. So till then, be safe. Have a wonderful time with your family. Have a wonderful.
One small correction. It's not on next Saturday, but on 15th, which is Tuesday.
Yeah, this Tuesday. Yeah, sorry.
Tuesday, Wednesday. Yeah.
Time you need to confirm. I told you 4 o'clock would have better. So anyway, we'll check. Check with.
Thank you.
Thank you.
Thank you very much,
Bye bye. Thank you.